Hey YouTube, thanks for visiting my channel. This is Chandan, and in this lecture series we are going to discuss the questions paper or question discussion of West Bengal set 2023. Okay, so this is the second session, and in the first session we will discuss some questions that is from 5 topics we already discussed. Those who are new, those who are not watching the previous sessions, I am requesting you to all, so please watch the lectures and attend these lectures obviously. Okay, so this is an instant live. Okay, I'm sorry for that, I'm not notify you. Okay, so sorry for that. And so this is the second class. Okay, so in this session we are going to discuss the papers or the questions of number 1 is classical mechanics, number 2 is fluid mechanics, okay, number 3 is Fourier transformation FT, and number 4 is the questions from Fourier transformation. Okay, there are 8 questions and we will solve these 8 questions in these lectures. Okay, so let's start, and those who are new in my channel, please like the session and comment if you have any doubt in the comment section below, and obviously subscribe the channel. Okay, so let's start. So the first question is this one, and this is a questions from classical mechanics. Okay, so it says that let H, T and V, and please comment once comments me that if the voice and audio and video are okay. Please comment once, those who are watching the live, so please comment once that audio and video is okay. Okay, then I will start to discuss. So please comment once, comments, okay, if the live or if the audio and video is okay. Hello, anyone is there? I think some people are watching, so please comments one if the session or if the audio and video is okay. Audio and video okay na? So please comment once that audio and video are okay. I think all are okay. Audio video okay? So chalo karte start to solve the first questions of today's session. So the first question is from classical mechanics. Okay, the question says that let H, T and V denote the Hamiltonian the kinetic energy. Okay, Ruchita, thank you for commenting. And the kinetic energy and the potential energy respectively of the mechanical system. Okay, at the time t, if H depends on T explicitly, then the value of del H del T is equal to. Okay, so see one thing that we all know that the Hamiltonian H equal to what? Summation pi qi dot minus L. Okay, where L is the Lagrangian of the system. Okay, now this is the Lagrangian, and we all know that the Hamilton's equations of motion are what? Summation so the Hamilton's equations of motion. So when we construct or when we obtain the Hamilton's equations of motion, then we get Hamilton's equation of motion. We get what? Number 1 is qk dot, which is the generalized momentum term. This is equal to del H and del of pk. Okay, this is what? The generalized momentum, and this is the generalized coordinate terms. Number 2 is what? Pk dot, this is equal to what? Minus of del H del qk. And the third one, which is most important, and we need these functions minus or this relation del L del T, this is equal to del H del T. Okay, so here we need this part, okay, or this result to solve these questions. Okay, see, we all know that generally we write L equal to what? T minus V, where T is the kinetic energy of the system and V is the potential energy of the system. Okay, therefore we have to find the value of del H del T. Okay, so del H del T, this is equal to what? This is equal to minus of del L del T. Okay, so this is equal to minus del T of L equal to T minus B. So this is equal to minus of del T del v, sorry, del t minus minus plus del v and del t. Okay, so this is the correct answer of the questions, del v del t minus del capital T into del small t, that is option C here correct. Okay, so in these questions you can make a mistake that if also you can solve using this relation H equal to T plus V. Okay, or H is the Hamiltonian, T is the kinetic energy and V is the potential energy. But here is a but. What is the but? So this is we get when the system is conservative, that is V is independent of time. When this function V is independent of time, in that case we can write H equal to T plus V, and then in that case del H del T equal to del T plus del T, sorry, del V del small t. In that case these options may be true, but in this case there is no connection or there is no such conditions given including V. Here it is not saying that V is independent of time or the system is conservative. So okay, so in general we solve this problem and the correct option is here option number C. Okay, now going to the next question, question number 45, and all the questions number are from X series. Okay, I must say once, so these all are X series question paper, the questions number are X. Okay, now going to the next question, question number 45. So question number 45 says that a rigid body, rigid symmetrical about z axis, has one point fixed on this axis. Okay, let w, this is equal to wx iota cap, and this must be plus. Okay, there is some printing mistake, you can say, plus wy j cap and wz k cap with the angular velocity of the body, then which of the following is true? Okay, so this is the question, and this questions made from what? Motion of rigid body. Motion of rigid body. Okay, so first we see what is the motion of rigid body. Okay, so given see the questions that there is no external force. Okay, so we first write the force free motion, equations of motion for force free phase, or there is no torque, extra torque. Okay, so we just write here the Euler's equations of motion. The Euler's equations of motions are what? Ix omega x dot, this is equal to what? Iy minus Iz into what? Omega y omega z. Second one is Iy omega y dot, this is equal to Iz minus Ix into what? Omega z into omega x. And third one is Iz omega z dot, this is equal to what? Ix minus Iy into omega x minus omega x into omega y, where Ix, Iy and Iz are the what? Principal moment of inertia. Okay, principal moments of inertia. And omega x, omega y and omega z, omega x, omega y and omega z are the what? Components of angular velocity, components of angular velocity, components of angular velocity along the principal axis. Okay, along the principal axis. Okay, so this is the equations of motion for a force free or torque free system if there is no external force. So in this problem, or you can read, if you read the problem, then see that there is no external forces is given. So this is the equation of motion of, or Euler equations of motion of the system. Okay, now if it says that it is symmetrical about z axis, therefore if the body is symmetrical about z axis and has one point fixed on the axis, then what is the equation of motion? From this equation of motion, in that case we derive the equation of motion equal to what? I change the color. So in that case the equation of motion remains Ix omega x dot this is equal to Iy minus Iz into omega y omega z, and it is the motion the rigid body is symmetrical about z axis, it is given. Okay, and one point fixed on the axis, on the z axis. Okay, so in that case we will get these two equations of motion, and the third equation of motion, that is what, omega z dot, because the moment of inertia is not 0. So in the third equation, from this third equation we get simply omega z dot, this is equal to 0. So this is the case. Okay, so if we get omega z dot, this is equal to 0, that means what, omega z equal to constant. That means the components of the angular velocity in the direction of z axis is constant. Okay, that means here the correct answer is option B. Okay, so this is the correct answer, omega z is constant. Okay, now going to the next question. The next question, question number 48, and this question is from fluid mechanics. Okay, fluid mechanics, and the chapter is motion in 2 dimension. Okay, the chapter name is motion in 2 dimension. Okay, now we solve the question first. So question says that if v equal to 2t I cap plus x j cap is the velocity of 2-dimensional fluid flow, and the phi x y t is the stream function, then phi x t equal to, that means we have to find the stream function. Okay, so this is basically applications of complex analysis, you can say, and we using here the what, Milne-Thomson method to solve this question. Okay, so it is given that the velocity component v equal to 2t iota cap plus x into j cap. Okay, this is the case. Now we write here one relation d psi equal to what, v dx minus u dy. I think this is the relation, yes I am right, and u equal to what, u equal to here minus del psi del y, and v equal to what, del psi del x. Okay, so now psi equal to what, if we integrate this term first, then we can write here that del psi del phi del y, from this equation we can write del phi del y, and the u component is what, u component is this one, 2t, u equal to here 2t and v equal to x. Okay, so del psi del y, this is equal to what, del psi del y equal to simply minus of 2t. Okay, and if we integrate with respect to y, then we if we integrate, then we get what, integration del psi equal to integration minus of 2t del y. Okay, so this is implies, this gives psi equal to minus 2ty plus f of x and t. Okay, so we get this term. Now we also get what, if we integrate or if we differentiate with respect to x, from this is, we need this equation, and del psi del x, this is equal to, this term gives 0 and this gives del f del x. Okay, now del psi del x means what, we need to find this function. So del psi del x means what, del psi del x means v equal to x. Okay, so that means we get del f del x, this is equal to del psi del x, and del psi del x, value of del psi del x equal to v, and v equal to x here. Okay, so this is equal to x. Now if we integrate simply, then we get f equal to x square by 2 plus a function, constant function, this is equal to t suppose. Okay, therefore we get what, we get this term and this term. Now we put the value of x to this equation, so psi equal to what, minus 2ty plus fxt, and f means here x square by 2 plus gt. Okay, so this is the answer. Which option? I think minus 2ty plus x square by 2 plus gt. Okay, so this is answer A. Okay, correct answer is A. Okay, now going to the next question. So those who are watching live, so please give a like to this session. Okay, so question number 49, which is again from what, fluid mechanics. Okay, so the question says that a circular cylinder of radius a is fixed across a stream of a fixed velocity u and the circulation k around the cylinder. Okay, the maximum velocity is, so this is again a problem from fluid mechanics, and the chapter from which these questions is made is motion of cylinder. Okay, motion of cylinder. Okay, so if we see the solution of this problem, then first we write the velocity potential of the motion. So there is a motion occurs, so this is the formula, or this is the result, you can say the velocity potential of the system. This is equal to, we write this term phi, this is equal to capital U into what, r plus a square by r into cos theta minus k theta by twice pi, where r is measured from the center of the cross section, the cross section of the cylinder. Okay, cross section of the cylinder. Then the velocity q is given by q square, this is equal to what, minus of del phi del r whole square plus minus of 1 by r del phi del theta whole square. Okay, so this is the velocity component q. So this is equal to what, del phi del r equal to what, we can calculate the del phi del r and del phi del theta. So del phi del r, this is equal to what, u into 1 minus a square by r square into cos theta, and what, del phi del theta, this is equal to what, u into r plus a square by r into minus of sin theta minus k by twice pi. Okay, so we put the values of del phi del r and del phi del theta to this equation. So minus del phi del r whole square, this is equal to what, just a second, this is equal to u square into 1 minus a square by r square whole square into cos square theta plus u into what, 1 plus a square by r square into, this is sin theta plus k by 2 pi, I think k by 2 pi r, this term whole square. Okay, so this is equal to, we can write this is equal to u square into 1 minus 2a square. If we write this term, 2a square by r square into cos of 2 theta plus a square by r to the power 4. You just check the calculations once. Okay, if I made a mistake, then you can correct me by pi r in the comment. Okay, into 1 plus a square by r square, I think this is not visible properly, so a square by r square into sin theta, this is this term sin theta plus k square by 4 pi r square, 4 pi square r square. Okay, so this is maximum with respect to r when r is minimum. Okay, so this q square is maximum when r is minimum, so we need r to be minimum. Okay, now when r is equal to minimum, that is we put r equal to a, because when r equal to a, then the value of r gives minimum, so we put the values r equal to a in the equation, in the last equation. If we put, then we get what, just write now. If we put r a equal to r, then this gives q square, this is equal to u square into what, 2 minus, you check the calculations once in your at your own. Okay, so this plus 2uk by pi a into sin theta plus k square by 4 pi square a square. This is equal to what? We get 4u square sin square theta plus 2 capital UK by pi into a into sin theta plus k square by 4 pi square a square. Okay, so this gives q square, this is equal to 2u sin theta plus k by 2 pi a whole square. Okay, this term. Now q is maximum. If q is maximum to respect to theta, then sin theta equal to what? Sin theta equal to 1, because at theta equal to pi by 2, sin theta gives its maximum value. So we put theta equal to pi by 2, that is sin theta equal to 1. Okay, then we put sin theta equal to 1, that is theta equal to pi by 2. Okay, then this equation reduces to what? Q square, this is equal to 2u, okay, plus k by 2 pi a whole square. That means what? Q equal to 2u plus k by 2 pi a. This is the required answer. Which option? 2u plus k by 2 pi a. I think it's option what? D. Okay, so this is the correct answer, and this is the problem from motion of cylinder from the fluid mechanics. Okay, now going to the next question. Next question, this is a Fourier cosine. So question number 62 from X series, and this is from Fourier transformation. Okay, so the question says that the Fourier cosine transform of e to the power minus of x square, this is what is the value of this. Now Fourier transformation of a function of any function, suppose fx, so this is equal to Fourier cosine here, so this is equal to integration 0 to infinity fx into cos x dx. Okay, this is the formula. Now we put the value, so this is equal to integration 0 to infinity e to the power minus of x square into cos x dx. Okay, now let this integration equal to I. Okay, so sorry, cos lambda x, here lambda is the transformed variable, cos lambda x. Okay, now we differentiate this with respect to lambda, so di d lambda equal to what happened? Di d lambda equal to integration 0 to infinity e to the power minus x, and this in the inside this del L del lambda occurs. Okay, so this is equal to, I just write one line, so del lambda of this term, and the other terms goes to 0 because these are constant term. So this is into dx. So this is equal to what? Integration 0 to infinity del lambda means minus lambda sin lambda x into exponential minus x square into dx. Okay, so this is the term, and this is equal to, we write multiplied by 2. Okay, 1 by 2 इंटीग्रेशन, ठीक है चलो लिखते हैं, इंटीग्रेशन 0 to infinity minus of 2, sorry this is x, this is not lambda, this is x, so this is x minus 2x into x e to the power minus of x square into sine of lambda x dx. Okay, this is equal to 1 by 2 integration 0 to infinity, we can write d of e to the power minus x square, which gives the e to the power minus x square into minus 2x and sine of lambda x into dx. Okay, so this is equal to what we can write if we integrate what by parts. Okay, so then this gives 1 by 2 into first term, if we write sine lambda x, d of this term gives simply e to the power minus x square into 0 to infinity minus 1 by 2 or yes 1 by 2. Rather this terms gives d of this terms give this term only, integration 0 to infinity to the power minus x square into what, sine lambda x means my cos, I think this gives this is I think cos of lambda x into dx. Okay, and here one lambda comes out from this integration, so this, okay, so this is equal to, so this term what, this term goes to 0 if we put infinity, and if we put 0, if we put infinity then this term 0, if we put 0 then this term gives 0, therefore the total term gives 0. Okay, and if we see the integration, then this is equal to minus lambda into simply I. Okay, so this is the integral I, so minus lambda by 2 into I. Okay, so this, now di d lambda means this, so di by I, this is equal to what, minus lambda by 2 into what, d lambda. So this gives log of I, we write log of I minus integrating constant log c, this is equal to what, minus lambda square by 4. Okay, minus lambda square by 4. So this gives log of I by c, this is equal to minus lambda square by 4. So this gives what, I by c, this is equal to I by c equal to e to the power minus lambda square by 4. This implies I equal to c e to the power minus lambda square by 4. This. Okay, now we have some another work. So this calculation is very big calculation, I must say. Okay, so see, now if we put I equal to 0 at the initial condition, we put I this at lambda equal to 0. Okay, so this gives what, lambda equal to 0 means c, this is simply c. Okay, now lambda at lambda equal to 0, I becomes what, that means c equal to, we put from here the value at lambda equal to 0, that means integration simply 0 to infinity to the power minus x square into dx, and we know that this is a common integration, and I think this question is already comes in the in the previous year's exam, only this integration. Okay, and I already solved this integration, and the value of integration, I think this is root pi by 2 comes by using the error function. So we get the value of c, this is equal to root pi by 2. Therefore I equal to what, therefore we get I equal to simply I equal to root over of pi by 2 e to the power minus lambda square by 4. This is the correct answer, but this root pi is not given in any of the 4 options. This is the fact. I think this is printing mistake, or in that case the questions may be wrong, because there is a root pi must comes. Okay, so this is the case, and if this root pi is not given, then which option occurs? If root pi is not given, then I think here option A correct, but I think we need a root under of pi in the numerator of the function or of the fraction. Okay, so this is the case of this question, and I think this is the correct way to solve the question. Okay, so going to the next question, the question 64 is again from Fourier transformation. Okay, so which of the following Fourier transformation, fx equal to 1 minus x square mod x less equal to 1 and in 0 whether mod x is greater than 1. So Fourier transform of any function, suppose this is fx, this is equal to what, integration minus infinity to infinity and e to the power iota lambda x into this fx into dx. Okay, so here fx means minus integration infinity to infinity, and see one thing, that this function is defined in two interval. One is -1 less equal to x less equal to 1. Only in this interval we have the value 1 minus x square, and the remaining interval the value is 0. Therefore we simply write here integration -1 to 1 1 minus x square into exponential iota lambda x into dx. So if we do this integral, then our problem is done and we get our answer. Okay, so this is equal to what if we integrate this by using by parts, then we get 1 minus x square into exponential iota lambda x by iota lambda to minus 1 to 1 minus integration 0 to 1, and this gives simply minus 2x ddx of 1 minus x square means, and integration this parts gives what it is iota lambda x by simply iota lambda into dx. Okay, so if we take common 2 by iota lambda, because 2 by iota lambda is common from here, and also this gives, if we put, see, if we put 1 then this gives 0, and if we put minus 1 then this term gives also 0, therefore this term goes to 0. So if we take common 2 by iota lambda from the second term, and then sorry, this is minus 1 to 1. Okay, then again integrate once by parts, then we get what we must get x into e to the power iota lambda x by again iota into lambda, and this is the integral is minus 1 to 1 minus integration 0 to 1 what I think this gives ddx of 2 common we take, this must x only here, so 1 into what the integration is e to the power iota lambda x by iota lambda again into dx. Okay, so this is the case, I think, yeah, sorry, this is minus 1. Okay, so this is equal to, we can write minus, so if we multiply this iota lambda to the outside of the interval, and here also we get once iota lambda, so here we just multiply 2 by iota lambda whole square. Okay, so this is, and if we put the limit of the integration for the first case, then we get here a 1 into e to the power iota lambda, so this gives simply iota lambda. Okay, and minus of minus 1 if we put, then this gives simply plus e to the power minus iota lambda. Okay, so this is the one case, and from this we again get 1 iota lambda in the denominator again. Okay, so this parts gives, and this parts gives what I think plus 2 by minus, we get minus 2 by iota lambda whole cube into what e to the power iota lambda we take already, so we get, I think, from this exponential iota lambda minus exponential minus iota lambda, this part. Okay, you must take once, so this gives what minus 2 by lambda square into e to the power iota lambda plus e to the power minus iota into lambda. Okay, minus what so I square gives minus 1, so minus minus gives plus 2 by iota lambda cube into exponential iota lambda minus exponential minus iota lambda. So this part I just change the color, or this makes opposite. So this is equal to what, if we take by 2 here and multiply by 2, then this gives what minus 4 by lambda square into cos of lambda. Okay, plus what simply, and if we gives 2i here, then this gives what, and here I already 1i present, so if we just multiply and divide 2, so we get 2i here, and this gives what 4 by lambda cube into a sine of lambda. Okay, so if we take common 4 by lambda square, then we get what 4 by lambda cube, then we get simply sine lambda minus of lambda cos lambda. So this is the final answer. Which option? 4 by lambda cube into sine lambda minus lambda cos lambda. I think it's option B, I think. 4 by lambda q into sin lambda minus lambda into cos lambda. Yeah, option B is correct here. Now going to the next question, and these questions from Fourier transformation. Okay, now the questions 57, and this question is from what? Calculus of variation. You all know that calculus of variation. So this is a very easy question. So it says that the variational problem of extremizing the functional I equal to this one. So y equal to y into 3x minus y. So we write f this is equal to y into 3x minus y. That means 3xy minus y square. Now we write the Euler-Lagrange equation. What? The Euler-Lagrange equation is del f del y minus ddx of del f del y dash. This is equal to 0. Okay, so del f del y means what? Del f del y means simply 3x minus 2y, and del f del y terms is not present in this equation, so this terms goes to 0, which is equal to 0. That means we get here what? Y equal to 3 by 2 into x. Get this one. Now y3 equal to, we put y3, this gives what? 3 by 2 into 3, so this gives 9 by 2, which is equal to 4 and half. So this is correct. But if we put y1, that is y equal to 1 in this equation, then this gives what? Y at 1, this is equal to 3 by 2 into 1, this is equal to 3 by 2, but it is given that y1 equal to 1, so this is not 1. That means this variational problem has no solution. This is very easy problem, and this is the questions from previous year of CSIR NET. Okay, this is the questions from previous year of CSIR NET. Now going to the next question. These questions, I think in the questions there is a mistake, or I may be wrong, but let's start to solve. If we write the Euler-Lagrange equation first, f equal to what? F equal to, it is given 1 plus y dash square by y. Okay, now this is what? Independent of x. Independent of x, and in case of independent of x, we must write the Euler-Lagrange equation. What? The Euler-Lagrange equation is, equations are what? F del f del y minus ddx of del f del y dash, this is equal to 0. Okay, so del f del y means what? Del f del y means, if I made a mistake, then you must comment me, okay, that sir you made a mistake here. Okay, so del f del y means what? 1 plus y dash square by minus of obviously y square minus ddx of del f del y dash means sorry, this is, I write a mistake here, sorry for that. So if independent of x, then this gives f minus y dash into del f del y dash, this is equal to constant. Okay, this is the equation of motion for independent of x case. Okay, so this gives 1 plus y dash square by y minus y dash into del f del y dash means 2y dash by 2 root under of 1 plus y dash square into y is equal to constant. Okay, so this implies what? Y into root under 1 plus y dash square is the LCM. So this gives simply 1 plus y dash square minus y dash square, this is equal to constant, suppose C. So this one, so this gives what? Y square into 1 plus y dash square, this is equal to what? If this we take C, then this gives 1 by c square. Okay, so this implies 1 plus y dash square equal to 1 by c square y square, and this gives y dash square equal to 1 by c square y square minus 1. Okay, so this is equal to 1 minus c square y square by c square y square, and this gives y dash equal to root under of 1 minus c square y square by cy. Now y dash means dy dx, so dy by root under of 1 minus c square y square, and this cy gets this side cy, this is equal to integration simply dx. This is the case. So this is equal to, implies if we put cy equal to suppose z, then we get what, sorry, c square y square. I think if we put 1 minus c square y square equal to z, then this gives what, minus 2y c square, this is equal to, put z square, then this gives 2z dz, and this is dy. Okay, so I think the question, so y dy, and this gives this one, so this implies what, minus y dy, this is equal to z dz by c square. We get 1 c square. Just once I forget this part. Just erase. Now this means what we get, y dy equal to minus z dz by c square. Okay, now if we put in this equation or in this integral, then we get what, c into y dy means minus z dz by c square by simply z, this is equal to x plus suppose any constant k. So this one c, when one c gets cancelled, z gets cancelled, so minus dz, this is equal to simply, if we multiply this c in this side, xc plus ck. Okay, so now z means we put the values of z, so this gives, if we simply integrate, I think, yeah, if we simply integrate, sorry, this is already integration, so simply z equal to dz means simply integration z equal to this one. Okay, so now we put the values of z means what, now if we square both sides, then we get what, z square, this is equal to c square into x plus k whole square. Okay, so z square means 1 minus c square y square, this is equal to c square into x plus k whole square. So see, this is second degree equation, you must say with x square and y square term, so we can say from here that it must be a circle. Okay, so if we simplify more steps, then we must get an equation of circle. We can obviously see this from the equation. Okay, so I think this is a circle. Okay, so I think circle is the answer. So this is the session, or this is the questions for today's. Okay, so in this session we take 8 questions of classical mechanics, 2 questions, fluid mechanics at 2 questions, and Fourier transform 2 questions, and calculus of variation 2 questions. These are most important questions also. I must say that the level of the questions from fluid mechanics is high level question. Okay, and Fourier transform also, because there is the calculation is very big calculation for the Fourier transformation problem. Okay, so this is the session for today, and this is the end of today's session. So please like, share, comments, and obviously subscribe the channel, those who are new in the session, or those who are new in my channel, and those who are new in my channel for the first time. So I'm requesting you to that, those who are not subscribing my channel, so please like, share, and subscribe the channel, and obviously you must share the session with your friends. Okay, so thank you friends, thank you. थैंक यू फॉर ज्वाइनिंग एंड चलो मिलते हैं कोई एक नेक्स्ट वीडियो में एंड आई थिंक in 1 or 2 or sorry we will continue the sessions of solution series of West Bengal set of the remaining topics also. So thank you for joining and it's 11:08, it's currently 11:08. So thanks for joining the channel, thanks for the live session because it's an instant live. Okay, so I'm not notifying you previously or before sometimes. Okay, so thank you for joining. Obviously, thank you, see you again in the next video.